Hey everyone, very good evening. Welcome to Adson Engineering Academy. It is today that we're going to handle this particular topic. But before we continue, please do subscribe to Adson Engineering Academy. It is actually a good site that will teach you all the engineering aspect that you need. So for today, we're going to handle one topic in strength of material. For those who are doing engineering, whether civil or mechanical, it's important for you. So let's dive into this particular topic, torsion. When you hear the word torsion, what comes in your mind? What comes in your mind definitely is twisting, because torsion, first of all, as a simple definition that I can give you, is the act of twisting. Is the act of what? Is the act of action, is the act of twisting. Okay, so when you hear the word torsion, this word should come at the back of your mind. Now, this torsion, if we're analyzing in the engineering aspect, for instance, when you have a particular material, or we call it a shaft. When you have a particular material, we call it what? A shaft. In this case, when I draw it, when I draw something like this, yeah. So this is my material. So if I twist it, I apply what? A force here, and apply a force here. Remember, this force is going clockwise, and this one is going anti-clockwise. So it is producing what? Torsion. It is twisting it. So in this case, I'm calling this T, I'm calling this T. So when I take a cross-section of this, I take a cross-section and call this part, from this part to this part R, and then apply force here. I call this force, maybe force what? F. So what will be my what? My T. My T is definitely going to be F times what? Times R. This is a very simple expression that I expect you to know from this particular topic. Yeah, definitely the series of expressions that we shall have, but for instance, we need to know what is the torsional what? Equations. So as an engineer and doing this particular topic, you should know what is torsional what? Equations. But before I take you to the torsional equations, there are some of the assumptions that are made when deriving this equation. So you should know the assumptions made when deriving this particular equation. So let's have a look at assumptions. So let's have a look at what we are calling what? What we are calling assumptions. Okay? Assumptions made when deriving what we call torsional equations. I will tell you what is torsional equation, but let's first have a look at the assumptions that is made. The first assumption that is made is that the material in this case should be homogeneous and what? Homogeneous and should be homogeneous, and what? And isotropic. Isotropic. The material should be homogeneous and isotropic. So when I say the material should be homogeneous, I mean it is what? Uniform. Isotropic, I mean it should have what? The same property in all the directions. So that's the meaning of what? Homogeneous. And then secondly, when you're twisting the material, okay, the material, before you twist it, it should what? It should have the same radius. Okay, before you twist it, the same radius. After twisting, it should remain what? The same. So the radius should remain what? The same in this case. Radius should remain what? Same. Radius should remain same before and after what? Twisting. Yes, so there are some other properties that you have to concentrate on, because if you check on this material that we use, these materials are basically considered to be what? Elastic. Okay, so the load is within the elastic limit. Okay, so dear students, when we're looking at the load that is being applied here, the load should be, okay, the load should be within what? Elastic what? Elastic limit. Elastic limit. So there are some other various what? Assumptions that are made, like the properties remain what? The same or uniform. The property of that particular material remains what? Uniform. So these are just some few. For the meantime, I'm going to take you through what we call the what? The torsional equation. So let's continue. Let me give you what we call the torsional what? The torsional equations. Yeah. Because that is the most important thing in this case. I'm going to give you the torsional what? The torsional equations. So let's look at what we call the torsional what? Torsional equations. Okay? Torsional equations. So for your informations, basically we're going to look at the equations and we have to solve somewhat engineering problems, because as we're twisting it, we need to know the equation, right? But after knowing the equations, how can the equation help us to solve what? Some of the problems. So let me take you through what we call the what? The equations. So here in this case, once we're dealing with these equations, I'm not going to give you the derivations, because In case you want that, you can inbox me, and then I will what? I'll do a particular video to derive for you the torsional equations. But for today, I'm going to give you only what? Only the torsional equation, and we solve some what? Some problems. Yes. Right. So let's look at the equations. In this case, the equations are quite simple. It is T out of what? This is what we're calling it J. Yes. It's equivalent to G theta out of L. Then this is equivalent to what? Equivalent to tau out of R. But you should know what are some of these what? These letters we're talking of. So what is T? T in this case is what? Is torque. T is torque. And when you're doing a calculation, you should know what is torque measured in. Okay? Because if you know torque, then this is what? Measured in Newton meter. When you're doing a calculation, it is easy for you to know. Then what about J? What is J? Okay, this is polar moment of inertia. Okay, so we call this one polar moment. Polar moment of what? Of inertia. Polar moment of inertia. So you should know that. And when it comes to this in a calculation, okay, because we need to know how do I get polar moment of inertia. It is calculated from the formula pi r to the power 4 out of what? Out of 2. So when you get to the calculation, don't get confused. It is J equals to pi r to the power 4 out of what? 2. Remember, r is what? Is d by 2 because it is diameter. Diameter divided by 2. So radius of what? Of axis. This radius of what? Radius from the axis of rotation. That particular radius, I remember, I've drawn for you. I've drawn for you the axis of rotation. What? Let's say this is what? Axis. So this was what? Our r. So you need to know that. And then what about G? Okay. What about G? Okay. So in this case, G is the shear modulus. Okay. We call it what? Shear modulus. So you should know this. This is what we call shear modulus. Okay. So shear modulus. How the spelling should be correct? Shear modulus. So this is what? Our G. Then we go to theta. Theta in this case is angle of twist. Angle of what? Angle of twist. Angle of twist. An angle of twist, you should know when I'm calculating, I have to measure it in what? In radians. So in this case, if they give you the question where the angle of twist is in degree, convert it first to what? To radians. And then what about L? L is the length of shaft. Length of what? Of the material that you're using. Length of shaft. Okay. Length of shaft. And this must be in what? A meter. Okay. So we're left with two terms here. The two letters here, if you can see. This is what? Tau. Okay. Tau. This is shear stress. Okay. Shear what? Stress. So this shear stress, remember, is the what? The stress that is produced due to what? Twisting. So it's shear stress. And then we have R. Okay. Definitely this one is in Pascal. Okay. Pascal. If we look at that, shear modulus, okay, is G. Okay. All these terms should be taken in Pascal. This one should also be in what? In Pascal. Then we have radius. Radius. This is what? Radius. I've already told you that that one is from the axis of what? Of rotation. So these are basically the terms that we use. And remember, you can play around with these equations and generate whatever you want. Okay. So one of the things that you can easily get is what we call torsional what? Rigidity. Yeah. So dear members, what is torsional rigidity? From this equation, can I twist it to get what is called torsional what? Rigidity? Yes. So if I take this equation, if I take this what? This part of the equation, okay, I can twist it to get what is called torsional rigidity. Okay, so I can raise this part. Okay, I can raise this part. I believe you have got the concept. Mind you, we're going to solve one problem here that will make you understand this very easily. Yeah, easy problem. Don't worry. So if I twist this equation, okay, I'll form what is called torsional rigidity. That is G, J. When I make G and J the subject in this case, so when I bring J here, it will form GJ. So that means I'll bring theta down here, then I'll take L here. So this will be equivalent to T, L, and then divide by what? By theta. Okay, so this is the expression of what we call torsional what? Torsional rigidity. Torsional rigidity. So you get a question, rigidity. If you get a question asking you to calculate torsional rigidity, just know that they want you to get what? G and what? And J. So this is as far as some of the little theory is concerned. In case you want derivations on the torsional equation, yeah, that I can make another video to explain for you that, but it's quite simple. Let's dive into one particular simple problem that will allow you what? That will allow you understand these equations better.